Hey everyone, welcome back to my channel. Today we are diving into one of the hottest tools powering modern AI applications, which is vector databases. If you have been playing around with machine learning models, embeddings, or anything related to semantic search, this is something you absolutely need to know. So this video is for anyone curious about vector databases, whether you are an AI developer, a software developer, a data enthusiast, or just someone curious about how AI can search and generate answers from large data sets. In this video, we are diving into vector databases, what they are, why they matter, and how they power things like RAG, which is retrieval augmented generation. We will explore Weaviate, one of the most powerful and popular vector databases out there, and I'll walk you through hands-on examples along with the most important concepts in vector databases like chunking, schema design, and dynamic batching. By the end, you will know how to set up your own vector-powered app using Weaviate and maybe even build your own AI assistant. So let's get into it. So first, what exactly is vector database? In simple terms, it's a type of database optimized for storing and querying vector embeddings, which are those high dimensional numerical representations of data like text, images, or audio. So instead of exact keyword matches like in traditional databases, vector databases allow you to perform similarity search, meaning they help you find semantically similar items, not just ones that match exactly. That's what powers stuff like ChatGPT's memory, AI search, recommendation systems, and many more. So why Weaviate? So now, out of all the vector databases out there, like Pinecone, Milvus, or Face, why am I talking about Weaviate today? Well, here's why Weaviate stands out to me. So first thing, it's open source and cloud native, which gives you flexibility whether you want to host it yourself or scale effortlessly using their cloud offering. Second thing is it has a built-in vectorizer, which means you can feed it in plain text and it will handle the embedding for you. Of course, if you have got your own embedding, it works great with that too. So the third thing is Weaviate supports hybrid search, which is two types of searches, which is combining, which is one is vector similarity search, and the second is keyword filtering, which is like a traditional keyword search. So it combines best of both worlds. And the fourth is the graph style API, which makes it super intuitive to interact with your data. So you can interact with your data in vector in Weaviate using GraphQL style APIs. Okay. So some cool ways now moving on to real world use cases. So why are we talking about Weaviate today and what are the real world use cases of Weaviate? So some cool ways Weaviate is being used in the real world include AI powered search engines. It is also helpful to develop chatbots that understand context and memory. Third is recommend recommendation systems, and fourth thing is image and document similarity apps. All right. So enough of theory. Let's roll up our sleeves and get into hands-on demo using Weaviate. So we are going to start by setting up a cluster on the Weaviate Cloud Service or VCS. So to start setting up a cluster on the Weaviate Cloud Service, you need to head over to console.weaviate.io. So this is the website of Weaviate.io, and there you can click on Try Now over here, and you will be directed to console.weaviate.io, where you need to sign up if you have not created an account in Weaviate. You need to first create an account, and then after that you will be able to sign into Weaviate Cloud, and your Weaviate Cloud console looks like this. And so to start setting up the cluster, the first thing that you need to do is go to the clusters tab over here, as you can see. And there I have created this cluster, but to save some time, but you need to create the cluster at the very beginning. So to create a cluster, you can click on this plus sign and there create cluster. After that, you need to choose your region. You need to pick a name and choose your region over here. Sometimes it gets automatically detected, but you can also change it. And It is easy as that. It will take some time to create this cluster, and after the cluster gets created, you will be able to see it over here. And your cluster will look like something like this, where you can find some REST endpoint, gRPC endpoints, and then you can also find some API keys. Two things are super important, which is the API endpoint, which I have shown here, and the second thing is admin API key, which is this, as you can see. So why these are important is they let you securely connect to your cluster from code. So we'll use this in our Python script shortly to start sending data and running vector searches. In the next part, I'll walk you through how to write a simple Python script to connect to this cluster, define a schema, import some data, and run your first semantic search query. So stick around through the end of the video. So moving on to some hands-on examples in Python. As you can see, this is a Python project that I have created in PyCharm. You can also use notebook, Jupyter Notebook. But for this video, I have used a PyCharm project. So I have created one example where the first step that we'll start is connecting to Weaviate Cloud. To connect to our Weaviate cloud cluster, I have created this function connect underscore Weaviate, and we'll use the API provided by Weaviate. And the two super important parameters that we need to enter are the cluster URL and authentication credentials. The cluster URL is the API endpoint that I mentioned you, which I have had shown you in the Weaviate dashboard. And the authentication credentials is the API admin API key that was provided in the that you can find in the Weaviate cluster dashboard. That's it. So after connecting to the Weaviate, what we'll do is the second step is creating a collection. So here we'll mention the name of the collection and the vectorizer config and generative config, which I will let you know in I'll let you know in some time what is the vectorizer config and generative config. So in Weaviate, a collection is similar to a table in traditional databases. It defines the schema for the data you want to store. Here I have created a collection named legal advice without any schema. I'll show you how you can create it with schema in the next example. But for prototyping, it's simpler to create collection without schema. So when you create a collection in Weaviate without explicitly defining a schema, Weaviate's auto schema feature comes into play. So this feature automatically infers the schema based on the data you insert. I mean, specifically the automatic property creation. So when you add objects with new properties, Weaviate dynamically adds this properties to the collection schema. So after creating the collection, you can verify whether your collection is created by heading back to Weaviate Cloud, and there you can find a tab named collections. You will be able to find this uh, collection that we created from the code. So after creating a collection, now this is an empty collection where you don't have any kind of data. So now the next thing that comes is loading some data into the collection. For that, I have created this function load data collection. And what I have done is I have loaded a data set from Hugging Face. So if you don't know Hugging Face, let me show you. You can load any data sets from the Hugging Face website. Hugging Face has a plethora of databases. You can see there are approximately like 3 lakh something data sets, a huge data set repository. So for this example, I have used the legal advice Reddit data set provided by Jonathan Lee. Let me show you how you can load this data sets into your from your code. For that, you need to select a data set from here. For now, I'm selecting this data set, and to use a data set from our code, we will navigate to this use this data set, and we'll click on data sets. And here you can see it has provided the code how you can import this data set from your code. So this is how I loaded a dataset called a legal advice Reddit. And what I mean by here split is I'll select the first 100 training data from this dataset. So when I print this dataset, I'll be able to see the first 100 training data of legal advice Reddit dataset. After that, I'll load the collection, and now you will find this part of the code little bit complex, where I have used something like batch and dynamic. So let me explain this part of the code. So first of all, let's understand what is batching. So batching refers to the technique of grouping multiple data operations such as insertions, updates, or computations into a single collective operation. So this approach is particularly beneficial when dealing with large volumes of data as it enhances efficiency and performance. Now that you have used batching, let's understand what is batch.dynamic that I have used here. So batch.dynamic method in Weaviate's Python client facilitates data insertion by dynamically adjusting batch sizes based on system performance and server recommendations. This approach optimizes throughput and minimizes the risk of overloading the server during large data import. So as you can see, because I have used batch.dynamic, I don't need to provide the batch size. So it will determine the batch size automatically, dynamically based on system performance and server recommendations. So now that you have understood what is dynamic batching, let's understand how it works. So first thing is context manager. So utilizing with ensures that the batch is automatically flushed, that is sent to the server when the block is exited, even if an error occurs. So you can see I have used with along with batch.dynamic. So that and one more thing you can see over here is error monitoring. So the batch dot number errors attribute tracks the number of errors encountered during the batch insertion process. In my code, I have used so in my code, if you can see that I have compared if batch dot numbers is greater than zero, and then if if number of errors are greater than zero, then I will stop the batch import. I'll break here and stop the batch import. So now that you have understood what is batch.dynamic, let's understand what are the benefits of using batch.dynamic. So first thing is efficiency. Using batch.dynamic reduces network latency by sending multiple objects in a single request, enhancing data import speed. So it sends multiple objects in a single request. So next thing is if we don't use batch, maybe it will send one data per request. So that's why batch.dynamic batching is useful for efficiency. The second thing is scalability. It automatically adjusts to the optimal batch size, accommodating varying server loads and ensuring stable performance. So as I mentioned that using dynamic, it makes sure that it chooses a batch size which accommodates different server loads, and it ensures that the performance is stable. The third benefit of using batch.dynamic is error handling. So as we saw, it provides a mechanism to monitor and respond to errors during the batch insertion process, which will allow for graceful degradation and recovery. So this is how incorporating batch.dynamic in your data insertion workflow with Weaviate offers a robust and efficient method for handling large data sets. So we saw that it automates batch size management, optimizes performance, and provides error monitoring capabilities, making it a valuable tool for scalable data operations. After inserting your data into the collection, you will be able to see the data from the Weaviate cloud from here. As you can see, this is the Explorer tool. Let me click on that, and from the Explorer tool, you will be able to, you need to select the cluster first, and then you need to select the collection, and you can see four properties in the legal advice. So this is, so you can see this data, and as you can see, the total object count is 100 that we have inserted first 100. One thing I forgot to mention was when you create a collection in Weaviate without explicitly defining a schema, Weaviate's auto schema feature comes into play. This feature automatically infers the schema based on the data you insert. It automates the property creation. So when you add objects with new properties, Weaviate dynamically adds these properties to the data collection, to the collection schema. So as you see here, I have mentioned one string, and next to it, I have mentioned the data set, the corresponding data. So according to this code, it should have created four properties: link, body, title, and label. So we can verify that over here. As you can see, any one data content, you'll be able to see the four properties over here and the corresponding data from the data set. So the second thing that Weaviate manages itself is the data type inference. So it Weaviate determines the data type of each property based on the value provided during insertion, and it infers the data type based on that. The third thing is it can infer the nested properties for complex data types such as objects and arrays. So this is how Weaviate provides the auto schema features. The last and the final step that remains is querying the data set. So I have created two functions like first query and second query to query on the data set with different queries. The first query that I mentioned here is provide some employment related advices, and I have printed the response that we receive from querying the data. The second query that I have created is my company is not paying my hospital bills after promising that they would. What should I do? So finally, so let's perform a semantic and query a database for entry similar to this given text. I already created the collection and loaded the data collection before this video to save some time. So I'll directly query the collection. And let's run this example and see what the query. So as you can see, it has printed client is ready, which means that we are now connected to the Weaviate Cloud Console. And the response received from querying Weaviate database is the some employment related. The first query that we did was employment, and so the response that we received from the first query is trying to get out of a job, which is which is related to the employment. And the second thing is working in other countries, so that is also related to the employment. Now, from the second query, we received some data which relates. Now, moving on to the second example, some differences between the first and the second example are like what I did different in the second example is I have focused on creating a collection with a defined schema, which we did not define in the first example. Then the second thing is I have done some chunking on a PDF document and inserted the chunks. We in the first example we just loaded the data sets from the Hugging Face and we inserted it into the data set. But the second example I will chunk a PDF document and then insert the chunks. And I'll explain you the importance of chunking later. So, and the third thing that I did different is performing RAG queries. So, in the first example, we just created simple queries. Now we will perform RAG queries in this example. The fourth thing is understanding single prompt and grouped task RAG approaches. So, I have demonstrated two RAG approaches, which is single prompt and group task, which I'll explain in a short time. So, the first thing I have done here is common, just like how I connected to the Weaviate cloud in the first example. I have mentioned a similar. I have created a similar function over here. So it connects to the Weaviate cloud using this API, and I have provided some more parameters that I did not provide in the first example, which is headers. The thing that I will do is creating a collection. Now here creating the create collection function is somewhat different that I have used in the first example. Here I have created a collection by mentioning the schema. So let me explain you what is the benefit for creating a collection with a defined schema. So this creating a collection with a defined schema ensures data consistency and clarity in the structure of our stored information. So while auto schema is convenient for development and prototyping, it's advisable to define schemas explicitly in production environments. So this practice ensures that data is consistent, which prevents unintended data type assignments and maintains uniformity across the data set. The second thing is the performance optimization. So it reduces the overhead of on-the-fly schema inference, leading to better performance. The third thing is it minimizes the risk of conflicts arising from inconsistent data structures. So I have also mentioned two more parameters. The first parameter is vectorizer config, and the second is generative config. So what is vectorizer config and generative config? Here, as you can see, I have used text to vec Weaviate as a vectorizer for this collection. So the text to vec Weaviate vectorizer enables Weaviate to generate vector embeddings for your data using its built-in vectorization capabilities. This means that when you insert textual data into your collection, Weaviate automatically converts this text into high-dimensional vectors that capture the semantic meaning. For generative config, I have used Cohere. As you can see, for generative config, I have used Cohere. Integrating Cohere's generative module enables like your Weaviate collection to perform RAG. In this setup, Weaviate retrieves relevant documents based on a query and then uses Cohere's language models to generate coherent and contextually relevant responses. You can find the modules that are enabled in your cluster from the Weaviate Cloud Console. So here's how you can find the modules that are enabled in your cluster. So you need to go to again the cluster tab, and then you can click on your cluster and you can see the modules that are enabled in your cluster. So I can use any one of this as a generative model or a vectorizer model. So now moving on to the next thing, which is chunking. So as I mentioned, what I did different in this example is chunking the PDF and inserting the chunks. What I did in the previous example was loading a data set itself from the Hugging Face. Here I will download chunks from a URL and insert those chunks. So as you can see, I have mentioned a ProGit URL here, and I have created a function which is download and chunk, which means what this function does is it will create a request on this particular URL, and what next it will do is it will remove all the multiple white spaces and then split the text by a single white space and create the chunk by joining a set of words into a string. So it will create a chunk uh, which has every word separated by a single space. And after doing that, what it will do is it will insert the chunks in Weaviate. I have used a chunk size of 150 and overlap size of 25, which means the chunks will contain some overlapping words, like 25 words in each chunk from the previous chunk, so that its meaning is preserved. So after inserting the chunks, you can visualize all the chunks in Weaviate Cloud as I explained you in the previous example. Now moving on to RAG, the next thing that we do will perform a RAG. So let me first explain what is RAG. So RAG stands for Retrieval Augmented Generation. It is a technique used in natural language processing that combines retrieval-based methods with generative models like GPT to improve the quality and accuracy of responses, especially when dealing with specific or factual information. So here's how it works in simple terms. So first, it will perform retrieval. When a question or prompt is given, the system first retrieves relevant documents or chunks of text from an external knowledge source. And in the second step, what it will do is it will perform augmentation. This retrieved pieces of information are then passed to a generative language model as context. And after that, the language model uses that context to generate a more accurate, informed, and relevant response. So the language model that we have used here is Cohere. It will use that context to generate a more accurate, informed, and relevant response. Here I have used two types of RAGs, which is single prompt and group the task. So let me explain the difference between both of them. This is a single prompt. Each retrieved chunk is individually used to generate a response. And the use case of a single prompt is when each chunk contains sufficient information to answer the query independently. Now, what is grouped task? So, in grouped task, all the retrieved chunks are combined and a single prompt is used to generate a comprehensive response. And the use case of the group task is when information is distributed across multiple chunks. It requires aggregation. So a grouped task is a prompt that is applied to a group of objects. This allows you to prompt the language model with the entire set of such results such as source documents or relevant passages. All right, now it's time to run the application and see everything in action. So let's check the output generated by our RAG query on the Git Pro content. And let me show you what query that we have performed on on a group task, which is I have asked to write a trivia tweet based on this text. And the query that I have used is states of Git. So What it will do is it will first query our collection, which is gitbook chunk, on states of git, and it will return two results based on this parameter limit of two. And what the group task will do, it will combine both of the response generated from the vector database, and it will perform this query or task on the whole group, which is write a trivia tweet based on this. It will combine. So it will what it will do is it will combine the results of both of the query of the responses generated from this query states of git, and it will write a trivia tweet based on this text. So let us see what it has generated. So as you can see, it has generated the response generated from the group task is the trivia git has three main, so five states: modified, stacked, and committed, and here's that. And after that, in the single prompt, what it will do is it will perform a query how Git saves data, and the vectors database will return two responses based on that. And what single prompt will do, it will perform query on both of this query individually, both of these responses individually, which means that it will perform translation of this text into French on both of the responses generated. So here you can see the chunk received from querying Weaviate database. Git stores everything in its database, not by file name and all, which is related to how Git saves data. And the response generated is it has translated this into French. And the second response that we received from Weaviate database is be efficient. The files have not changed. Git doesn't store the file again. And the response that we received from the single prompt is it has translated that text into French. As you can see clearly the difference between group to task and single prompt. Only one final response was generated from the group task, whereas from the single prompt, there were two responses that were generated. Now that we have learned all of this, let me recap all that we discussed in this video. We started by understanding the basics of vector databases, what they are, how they work, and why they are essential in modern applications. Then I introduced Weaviate and I shared why I chose to highlight it. It was open source, it's open source, scalable, has built-in vectorization and generative AI support, and is easy to deploy via the cloud. Next, we dove into our first hands-on example. I showed how to connect to a Weaviate cloud cluster, create a collection without a predefined schema, and load a dataset directly from Hugging Face. We talked about how Weaviate can infer the schema automatically, and we explored how dynamic batching helps efficiently ingest the data. In the second example, we switched gears and worked with a PDF, the Git book. This time, I defined a schema explicitly, broke the content into chunks, and explained the importance of chunking for better retrieval and generation. We inserted those chunks into the database and ran RAG queries. We also covered the two RAG approaches, this single prompt where each retrieved chunk is answered individually, and group task where multiple chunks are used together to generate a consolidated response. And finally, I ran the app and showed you what the actual generated output looks like. By now, you should have a solid grasp of how to use Vivier to build powerful real world AI applications using vector search and workflows. If you found this video helpful, please make sure to give a thumbs up and subscribe for more deep dives into AI, machine learning, and real world tools like Weaviate. I have dropped the full code and resources in the description below. Feel free to fork it, tweak it, and build something cool. And if you have got questions or if there is something specific you want me to cover next, drop a comment. I read all of them and I would love to hear what you are building. Thanks for watching, and I'll catch you in the next one.